Good morning, everyone. I'm here to talk about writing C++ modules in Node.js, which is a little bit of a weird thing, considering the nature of how Node.js works. But sometimes you need to. So who am I? My name is John Reynolds. I'm the lead developer for the recognition team at Accusoft. And what does the recognition team do? We tackle some really difficult machine vision problems. These are things that are conceptually easy for humans to do, but are really difficult for machines to do. So we have SDKs for stuff like barcode recognition, forms processing, OCR, ICR, stuff that's, we have to deal with things like noisy images, warped images, perspective warping, all that stuff, lots of math involved. So we have to pay very careful attention to making sure, we hit all the cache, we get all the cache hits we can, and, our algorithms are optimized for speed and efficiency. And that means that because of that, all of our source code is usually written in C++, because it's, the easiest way to get down to the bare bones for that. So why would you write a C++ module in Node.js? I'd say the number one reason you'd want to is if you have a lot of very busy code, lots of processor-intensive code. The JavaScript thread for Node.js runs single-threadedly. If you're doing a lot of processing, doing like a big for loop in that one thread, you're going to tie up that JavaScript thread. Now, it's not to say that Node itself is single-threaded, because as Jameson would point out, that Node itself does fire off additional threads. Like, for example, any hard drive access, any socket access and stuff like that. Anything that requires hardware, it will throw off different threads. So if you have a lot of intense processing, it's very useful to throw that in a new thread. So additionally, if you already have C++ libraries that are not currently available for Node.js, like you're trying to use a scientific library or something of that nature, or you've written something at your company already in C++. If you're trying to pass around lots of native, or think like, for example, if you have like database handles that need to be done on the native side and need to be passed around in memory, and you need fine control of when they're created or destroyed, that's another useful scenario for this. And ostensibly, if you just need to throw processing power at a scenario, that's a good usage of writing something in C++ and then just interfacing it with it in Node. So what we're going to go over in this talk, very briefly, is we're going to create a basic C++ module that'll run worker code in a separate thread. We're going to go over some tricky memory situations that we've come across. For example, trying to keep track of when JavaScript objects are destroyed, collected by the garbage collection. And also go over some helpful tips and tricks we found with the NaN library and with the V8 engine. So for our basic C++ module, we're going to be doing a very simple function with our API, right? We're just going to be simulating something that's processor intensive. In reality, what we're doing is we're just doing a for loop 1,000 times and incrementing a number. So this is the first thing I want to point out. This is how you'd actually link to the built C++ module in your code. I recommend not doing this as part of your, if you're packaging a package for NPM, because you'd probably want your main target to be a JavaScript file and have that one link in directly to your build Node module. The reason for that is because that JavaScript access point will basically be able to extend your API, add promises to it, do any customization of that nature. So again, this API function that we're going to be developing just adds 1,000 to a number, but doing it via a for loop. So the first thing you create in many Node applications for packaging is a package.json file. The one thing that we're going to point out here is the two dependencies. There's nan, which is the native abstractions for Node library, and the Node.js library. That is a Node version of the JIP program that is used in Chromium to handle all their build stuff. So in addition, we have an install script here to run Node.js. You don't have to add clean to this. This is just for making sure it's all nice and tidy. But that will automatically clean your build, configure it, and then actually execute the build. So pretty much all C++ programs of any decent size will usually have some form of make file or other thing like that. In this case, for Node.js, this is done via the binding.jip file. That'll include things like your target name, any source code files that you're doing, any include directories, any libraries that you're linking to, processor definitions, anything of that nature. We've also found that if you're linking other libraries in a different location, it's useful to define the RPath to make sure you can find those. We had fun with that. Now, one thing I want to point out is this. These files allow for shell instructions to be run as part of a kind of expansion. So in this scenario, we're actually causing Node.js to be run to find out where the nan location exists. So instead of having to hard code a location, which may be different for each individual user, we can actually just have Node itself tell us where nan exists. So this is going to be the kind of front end of our C++ module for Node.js. The first method that we're going to go over is the actual function that we're defining, the one that we're exporting. So nan provides a macro nan method which allows for a couple helpful things. One is the info array. The info array is the arguments that are passed to that function. So this allows you to take any JavaScript objects that are passed to that function and do what you want with them. For example, in this code here, we're turning the first argument of that function, which is a JavaScript number object, and we're casting it down to an integer, a native integer. The second is a function in JavaScript, and we're turning that into a nan callback object. Once that's done, we send it to the asynchronous queue worker class. This is a really helpful class. It does all of the threading you could possibly need, and it does it behind the scenes. You don't have to ever invoke libuv or anything like that. It will handle all of that. It will send off the thread. It will make sure everything's nice and partitioned in terms of memory. And we're providing an overloaded class, a subclass, if you will, of async worker that we're gonna define in the next set of slides. So when you require a project in Node, you get a variable back. In this case, the nan module init is what actually defines what that variable is that we're going to get back. So that's the target aspect of this macro. So here we're adding our function that we just defined above. We're adding that to what's returned in the public API of when we do that require call. And finally, C++ modules do require a node module call. This is just a way so that the linker can determine whether or not this is an actual Node.js module, and you can actually run stuff with it. So then we have our actual test worker. This is the header file for it. So a lot of this is mainly boilerplate code, but one thing, this is a subclass of the asynchronous worker class that's provided by nan. Now, two functions I want to bring to light are the execute function and the handle OK callback function. These are overloads of the asynchronous worker class. Additionally, although for point of brevity I did not include that into this example, there's the handle error callback. You have the ability to, if an error occurs in your native code, you can set an error and that function will call instead of the handle OK callback. So now we get into the meat and potatoes of our example app. This is where we're going to be doing the actual processor-intensive code, the for loop. In reality, you're probably going to be doing much more interesting things with this. But for our purposes of example, we're just going to increment an internal number 1,000 times. So now, one thing to note is this execute function is actually done in a thread that does not have access to any JavaScript objects. It doesn't have access to any of that memory system. I'm going to go over that in a couple slides, but it's very important to note that. Now, the handle OK callback, on the other hand, does have access that takes place in the JavaScript thread. So whenever we create new JavaScript variables, it's very important that we allow them to be garbage collected. So in NaN, it has a very helpful thing, which is the handle scope. There are other types of this. There's handle escapable scope. For example, if you want to return a JavaScript object up a function. But this is very easy. It's kind of almost plug and play where you just drop that in a function if you're creating new JavaScript objects. So now that we've done our kind of extensive calculation, if you will, the for loop, we're actually going to return that new value back up through the callback. So to do so, we now have recalculated a new number. We've added 1,000 to it. And we're going to turn it into a JavaScript variable. So that's what the first line is doing. And additionally, we're going to call the callback function that we provided to Node. And so to do that, most Node callbacks always start with the error as being the first argument to the function and your result as the second argument. So in this scenario, because there were no errors in the calculation, we return an undefined, or anything really that's falsy you can return. And we're going to return our JavaScript variable as the second argument. Then we're going to invoke the callback. So what happens when we run this? It's a good thing this is all slide code and not live code, because we were having fun with that last presentation. These are the files that are in your directory. And just by running npm install, it will automatically compile those C++ files, and it will create a .node file. Now that .node file is really just a shared object file. It's basically a DLL or other shared library. And when we run our little test program, we'll see indeed that the resultant number was 1,020 when we provided 20 as an input. So you can see it did the calculation in a separate thread, and it returned back, after a little bit of marshalling, the correct result. Now, that was a very basic program. It turns out there's a lot of, let's just say, intricacies when you're dealing with real-world issues. So we're going to go over a couple things that we found while going over some of our other projects. Some things of note, just helpful information. Oh, just kidding. So, the great memory firewall. You shall not pass. Never, ever attempt to create or access your JavaScript variables in your worker thread. This is because it does not have any access to any of that memory space. If you try, you're going to have a seg fault, and you're going to spend a while debugging why are my variables all turning into null. FYI, don't do it. So the question becomes, if we have our data that's written in Node.js and JavaScript, how do we actually do any meaningful calculations on it? And the answer is that you have to marshal it across the boundary. So that means you're going to have to take your JavaScript variables, turn them into native types, right? Integers, strings, things of that nature. Send it across, do your calculation, and then send it back. Now, yes, this is overhead, but usually the performance gains you'll get by running your processor-intensive stuff in that C++ environment will usually be more than the overhead involved in marshalling. So there are cases where you will have native data that you want to pass around a library, for example. We had examples where we had result objects from a certain type of calculation that you can call into, right? And anytime you were calling a function on that, it would access a native pointer that would go to our libraries, come back, and go back to the JavaScript land. But we needed a way to tie a JavaScript object to the native pointers, in other words, so that we could have that connection between the JavaScript and the C++ side of things. So if you want to make sure that your data does not get accidentally destroyed in JavaScript land, V8 very helpfully has internal field pointers for JavaScript variables. These are kind of hidden from the user. They're not really ever exposed, I don't believe, in the JavaScript land. And this is a way where you can basically set any custom data you want, any custom native data you want to JavaScript objects. Now, there are a few quid pro quos. You do have to make sure it's an object template, which you'll usually define in your initialization of the module. But this is a very handy way of tying your C++ library to Node.js. Very helpful. Going along with that, one of the biggest problems we had was it's fairly indeterminate when JavaScript will be done with an object. And so we had native objects that needed to be deleted on our side, right? On the native side of things. So JavaScript we had no way of knowing, hey, when's JavaScript done? When can we clean this up? Otherwise, we're just going to keep creating native objects till somewhere down the line we run out of memory. So in JavaScript, when you refer to another object, when you create a reference to another object, anything that's live that's referencing another object, that thing cannot be garbage collected because it's currently being accessed by something, right? It's being referenced. So we are allowed to create on the V8 engine, and technically the WREF library on the Node.js side allows this as well, which is effectively what we're doing here. You can create weak references. Now, weak references are a way of sort of just pointing at a JavaScript object, and you're able to say, let me know when this is garbage collected. So this functions effectively as a destructor on the JavaScript object, because hey, it's just been garbage collected. So here's an example of how to do it. I know it's a lot of code. As it so happens that many difficult things require difficult code. But it turns out when you actually do it in practice, it's a lot easier than it looks upon first glance. So the first thing that we're going to do is we have a JavaScript object, right, that our user is passing around, and we want to associate some native memory to it. We want to associate something that we've created on the native side with this. And we want to know when that JavaScript object has been garbage collected, if we can actually delete this native memory, right? We can free up the resources, we can clear the handles, we can do anything we want with it, right? So to do this, there's a little bit of hand waving going on in here, but we have to set a weak reference to that JavaScript object. And in doing so, in that call to set weak, we provide a function, an argument, which is a function That's going to be our cleanup function. This is a callback that is called into C++ land when that JavaScript object has been garbage collected. So this is our implementation of cleanup. Nan very helpfully provides a nice and easy way of getting that data that we've associated with it. And here, we're cleaning up that local memory, that native construct that we've created, and deleting the encapsulating object that we were used to track it. Now, anybody who's tried to debug memory issues in garbage collection knows it's not fun, especially trying to figure out when garbage collection occurs. We had a case where we were running it through our test suite, and then 10 minutes later it would crash from something that occurred a long time ago. So luckily, Node allows you to force garbage collection, but to do so you have to call the expose GC flag on Node.js. This allows you to have access to the global.gc function, and this will force garbage collection. So anything that isn't referenced, anything that's cleared out, will be cleared up by garbage collection. So if you have any logging internally while you're trying to develop this, it's very useful to see, hey, this has actually, in fact, been cleared out. So one of the kind of final things that I'd like to go over is we do a lot of work in the recognition team with images. And images are most of the time referred to in Node.js. They're passed around via the JavaScript typed arrays. Now, typically, when you're accessing array members, you have to do it one index at a time on the C++ side of things. You say, what is this pixel? What is this pixel value? What is this pixel value? That's not very efficient. In fact, if you're trying to marshal via that method, that's going to be a big slowdown. Don't do that. So the old way of doing this in V8 was very painful, and I don't think I saw consensus on how to do it correctly online. But luckily, Nan provides, as of Node version 4.0, I don't believe Node pre-v4 had access to the typed arrays, that particular manner. It allows the typed array contents class. This is a way of basically getting a native pointer to that memory. So instead of having to access each pixel one by one, or each array member one by one, you now have been able to cast it to an integer array where you can just memcopy the entire thing. It's very quick, very efficient. So in summary, sorry, it was a little quick. C++ modules allow very fine-grained access to what you're going to actually be doing under the hood with your library. There's a lot of stuff that V8 can do that I didn't really necessarily go into here. You'll just have to take my word for it. It's very powerful, and a lot of stuff that, for example, even Node.js exposes isn't necessarily the full superset of what there is to do. So it's also very easy, as I showed you in that minimal code example, it's not that hard to create worker threads that'll do really heavy lifting code. If you have really processor intensive code, it's really easy to spawn a new thread to do that. And again, if you have already written code, your company maybe, you have a group that's written C++ code, C code, it's very easy to link with that using, for example, the header file, which provides compile time, checking to make sure that you're actually using the correct invocation of those functions. So unfortunately, documentation is minimal. Trying to scour information on what actually goes on under the hood with V8 is difficult. There exists groups that'll discuss a lot about this, but you'll find that V8 changes a lot. Now, one of the good things about Nan as a library is that Nan is designed to be Node version V8 version agnostic. So no matter how much the interface changes for Node, Nan itself will try to keep as constant a interface as possible. That way you as the developer don't necessarily have to worry about doing all the if-defs based on what version of V8 you're using. Nan will take care of that all under the hood, and all you have to do is effectively do your functionality. And the other fun thing about developing V8 that we found was that even small mistakes throw massive compiler errors. It's not uncommon if you have a slight misdefinition of a JavaScript type to have a screen-long compiler error warning list, error list. It can make things interesting to trace down what actually just occurred while you broke the compiler. But with practice, it gets easier, I swear. So some references. I highly recommend, if you're ever going to be writing a C++ module, I recommend checking out Scott Free's introductory tutorial on building an asynchronous add-on using Nan. That was a great work for us when we were initially getting started. It doesn't cover some of the more advanced stuff that we've briefly touched upon. Definitely check out the Nan docs and JIP docs. They're both very powerful libraries, and yeah.